All right, so without further ado, let's start. So this is Shotan from SCU, and thanks a lot for joining us. Today we'll be talking about our EVMS1, the new product we have just launched, which is a battery system and the EV charger, both together, and we call it like the hybrid system of the solar, battery, and the EV charger. All right, so we actually did a lot of like conversation with already like who bought the chargers from us, and actually this is a global challenge for the EV infrastructure. So because like um, now the cars are getting bigger, the batteries are more big, and it needs more power to charge. But there is a problem from the grid that maybe I want a 240 kilowatt charging system, but the grid only allows me to have 50 kilowatt or 100 kilowatt, something like that. So the grid power, it's not enough. And because the EV is like booming every day, but to cope up with the electric vehicle, the grid is not ready yet. Sadly, yes, yeah. We see that in a lot of different zones, a lot of different countries, that the EV, like the grid, is not enough to power up the cars, a lot of cars, because we need a lot of power. And the second one is, of course, like the lack of charging speed, because like nobody wants to charge for 2 hours right now. It's 2025, right? So, and 60 kilowatt, 30 kilowatt, or 50 kilowatt, it doesn't satisfy the users, because everyone wants to just, park the car and grab a coffee and then maybe go to supermarket to buy something. So it's like they have less than an hour to top up the cars. Of course, they would like to have more supercharger compared to a slow charger like 60 kilowatt or 30 kilowatt. So according to our experience, what we have seen now from the past 2 years, the it's changing. I mean, the demand, it's changing. We used to sell 60 kilowatt, 90 kilowatt, a lot of 60 and 90 kilowatt in the past. But from following like last 2, 3 years, it's not a written statement, but it's just from our experience. The people who put order to us or ask for the quotation, it's always 180 kilowatt. So of course we know we have, for the EV charger, we have two different fleets, right? We have a commercial fleet, which is like for the public charging station. Then we have industrial fleet, which is for the bus and the trucks, correct? So for the public charging station, 95% of the quotation request we get, it's 180 kilowatt. And for the industrial fleet, we get, it starts from 240 kilowatt. So 240 kilowatt, 360 kilowatt, 480 kilowatt, something like that. So of course, like we cannot deny that now we need more charging speed, and more charging speed means we need more power from the grid. All right. We have seen that in the past, we tried to do some projects, or our clients wanted to add the solar system to the charging area. So it also created a lot of problem, because the solar generation is, the efficiency is low, because we know that it depends on the weather, right? Yeah, we all know that the solar, it's not a constant power generation. So it has its disadvantage, of course. So that adding a solar also doesn't solve the problem of having insufficient grid. Okay, and the fourth problem we see that when our client starts this business, EV charging business, and he wants to, add more chargers, he wants to open up more charging stations, or the end users, they want to have more and more chargers. So the scalability face a lot of challenge. I will give you one example. Like one of our client, he bought like 480 kilowatt of the charger, and then the grid allowed him like 520 kilowatt, 500 to 550 kilowatt, and then the business was okay. Business was doing great, and then he wanted to add more chargers, but it was very hard to apply for more powers from the grid. So yeah, we know it's a big challenge to like adding up more power from the grid. And of course, this is the most core thing, most core problem we want to solve is this low ROI, the return of investment. So in the worst case scenario, we have seen like some clients, they wait 5 years or 4 years or 3 years to get back their investment, the money they have invested. So it's all because of the power, the grid's power. Now, to solve all these different problems, of course, we came up with a solution which is called the solar battery energy storage and the EV charging all together. So using a solar and the battery, the BESS, because you know that we are a manufacturer of battery energy storage system as well, and EV charger. So combining all our technology into one solution. By the way, this picture is not a concept. Actually, it's a practical picture. It's a real picture. It's not illustrated by software. So it's we already have done this project in the overseas. So it's already running for more than 1 year already. But we had some problem. Like we got some feedback from our clients that why we don't make something very compact, doesn't take a lot of space, and the installation is not so, like you have to add the solar into the battery, grid to the battery to the EV charger, right? It's a lot of different connections. To bring up more flexibility, I already have changed to the next slide, but I will wait 6-7 seconds because of the latency of internet. Yeah, hopefully now you can see my screen now. So we have released this new product, which is, we call it EVMS 1. And this is a compact solution, which is you have the EV charging and integrated lithium battery pack inside, all in one. Everything is inside. So no need to add a lot of different connections between, because every setup is done before we send the product to you. So when you receive the product, it's just, you just put it on the ground and add some cables, like the input cables, and it's very fast. So allow me to introduce you some of the features of it. So it's very compact. The design is very compact. So you can add the solar, battery, and the EV charger. It's all together into one cabinet. Very compact, takes very less space. If you compare to a traditional solar, battery, and the EV charger all together. And of course, the next one, which is very important, why we had engineered this product, is like, because the installation is very fast compared to a traditional solution where you have to install different components first and then connect them together. So maybe it would take like a team of less than 10 engineers to work for, let's say, 2-3 days. And now everything is already pre-installed, pre-integrated into the cabinet. So it's very easy. You just connect the A, B, C, ground, and the neutral into the system. All right, I'm just accepting more people to the webinar. Yeah. All right, great. So yes, so installation is very fast, right? And of course, the cost, the installation cost. because you don't have to hire more engineers to work for you, and the installation time is more like much less now. So the installation cost is of course very lower. It's just like plug and play solution. Just connect the cables and that's it. Yeah, do some settings. It can be installed, operated, and ready for charging within 1 day. The same day, like you can finish everything in a day. Okay. And of course, like it has another advantage that if it's portable, like let's say you are doing some temporary charging. I have seen like Tesla tend to make some, like some competitions, like the electric car competitions, and it's quite remote area. So they make some this kind of solution, of course, in bigger scale, and yeah, charge the cars. So if you need a temporary, let's say some events or some requirements, and you will move you can rent to someone else this charger. So it's not a fixed one because it's pre-installed in this cabinet, and there is a possibility that you can move the product from here to there. So it's portable as well. All right. And the next is like we are using DC-DC power module. So why DC-DC power module? So our traditional one, it's the AC-DC. So like the battery is DC. Of course, the solar is DC. So we thought to use DC-DC, which makes more sense because the efficiency will be higher, more higher than AC-DC power module. And of course, lossless energy transfer. So we don't have to do a lot of transferring or transformation from AC to DC and DC to AC again. Yeah, so yeah, it's a much more efficient solution when we use the DC-DC power module. So of course, the main reason or the core reason and the main problem it solves, you can have maximum power capability with minimal grid power input. So now you can have 120 kilowatt of charging when your grid is giving you 30 kilowatt or 50 kilowatt or something like that. So you can grab more cars, or you can have more charging power when the grid is very low. So that's the main problem this product solves. You can have a charging stations when the government just gives you very low grids or maybe no grid at all. You can use solar, charge the battery, and then charge the car. I have prepared some different power flow. I will explain you how the power flows between different components or different aspects, right? So that's the LFP battery pack is installed inside this cabinet. And of course, we make the battery pack. So everything you get, that's another advantage that we are not trying to, buy battery packs from someone else and integrate into the system. With the advantage we have that we are a battery manufacturer, we manufacture the battery energy storage system. And so all the core components we use in this product is all engineered, innovated, and manufactured by us. So yeah, that's another advantage you can have from this product. So yeah. All right. So the advantage of using DC-DC power module, that the efficiency is higher. Now the peak efficiency with the DC-DC power module, it's 98%. And we are using now 40 kilowatt of the DC-DC power module. Before we used to have 30 kilowatt, now we are using 40 kilowatt power modules. Great. And please, you can ask me any questions in the chat box. I will check, and I will try to answer your questions. And if not, I will take notes and I will reply you by emails. So please don't hesitate to put your questions or any queries you have during the presentation. I try my best to answer them. Cool. Okay, so let's move on. Yeah, allow me to explain you some of the specifications of the chargers, the EVMS one. So the reason we call it, okay, I got a question. Yes, please stick with me. I will explain you like how the solar PV is connected with the system. So I have prepared some slides for you to answer the question. All right. So the product name is EVMS1. So I think most of you know already that our charger series is called EVMS. So EVMS1 means it's an extension of EVMS series. That means it's actually prioritizing the EV charger. So we are adding a battery pack to an EV charger, not adding EV charger to the battery. So that actually has a lot of meanings that when we started to design this kind of product and try to engineer this kind of product, our main priority is the EV charging. So to solve the limited grid problem, we decided to add the battery pack into the EV charger. So basically, this product is prioritizing the EV charging. This is why the product is called EVMS. One means everything is packed together. It's very compact solution. All right. It's a hybrid solution, and it has like traditional, what you see, our cashless payment terminal. So it has every feature you get from our EV charging products. So it's equipped with the OCPP. It's like a standard OCPP 1.6J, full and security certifications. It has basically the same controllers we use on the EV charger, same algorithm. It's just we are making an extension of the battery. We are integrated a lithium battery into the product. And the UI and everything will be like very familiar if you use our EVMS series EV chargers. Great. Of course, like now you have faster ROI because you can have massive power, more charging power with the help of the battery. Doesn't matter how much grid is giving to you. Also, like with the support from the solar, right? This bigger display, we always wanted to try to generate more revenue when the product is in standby mode. So you can put the advertisement into the display and generate more revenue when the charger or when the product is in standby. Okay, the dimension. So the dimension, it's like for the length is 2.9 meter, right? And the height, it's like 2.05 meter. And the depth, it's 1.1 meter only. So basically this kind of dimension, it fits in any charging area. We try to keep it as compact as possible inside. But of course, like we cannot compromise with the heat dissipation of the battery, right? So this is the best we could engineer for you guys. Yeah. So we tried to make it as compact as possible. All right. Let's look at the charging specifications. So the charging power, this is our standard product, right? So all the specification I am providing to you, it's standard. But maybe if you want to modify something like if you want to get more power or less battery, yeah, we always welcome your ideas, right? Okay. So the standard product, the standard specification is the charging power. You have 120 kilowatt of charging power. And of course, it's a dual gun and it's CCS2, double CCS2. And each gun is 250 ampere. And the cable, the gun we're using is called Amphenol. Actually, Amphenol is a quite known brand in the market. And the cable distance, the length is 5 meters. The charging voltage range, it's starting from 200 volt to 1000 volt DC. That means you can charge any car which starts the battery, the EV's battery starts from 200 voltage and maximum 2000 voltage. That means you can charge any cars in the market running on the street now. Communications, like, of course, it's a CCS2 communication protocol, the CCS2 standard. So it has ISO, DIN, OCPP 1.6 JSON, and it will be expandable to 2.0. So when we release the 2.0, it will be just one software upgrade. You don't have to pay any additional fees, or you don't have to do any modification on the controller. So the controller's hardware is already ready for OCPP 2.0.1. It's just when we release it, just one firmware upgrade, and you have 2.0.1. And of course, out of cost. And our remote management system, so our SCU remote cloud. So that will be all the communications it is integrated with. Let's look at the input grid you have to feed. So of course, it's traditional three-phase ABC, neutral, and the ground. And this is a TNS system, which is very safe and reliable system because of the isolation of neutral and ground. And yeah, the frequency, it's 50 hertz. And the voltage range, it's 400 volt, plus minus 10%. Okay, I think just take one question. How about charging trucks? Is it also possible to, of course, like you can charge the trucks, of course, as well. Not only the cars, trucks, but like as long as this is a CCS2 truck, of course, why not? Can it be scalable? Means higher power, 160 to 240, means more another capacity battery packs instead of 280 ampere hour to 314 ampere hour, for example, to be higher for such a power, and about battery packs all air cooled. Okay, great. Yes, it is possible to make it more higher power with a more higher discharge rate battery. So yeah, that is we are not limited into this. This is our standard product, and we want to hear your the purpose of having this webinar, that we want to hear your ideas. So we want to hear your questions, your ideas, your suggestions, so we can give you much more better product and answer to your questions. Yeah, we can boost the power more than 120 kilowatt and change to more higher cells, battery cells. Yeah, to give you more powers. Yeah, and I have prepared one interesting product for you. I mean, interesting solution in this slide. Yeah, please stick with me. With OCPP 2.0, V2G features will be there. Does power module support that one? Okay, so the power module we're using, that's the DC power module. So basically it's unidirectional, not bidirectional. But as you know that our systems, they are very flexible and modular system. So we are working on developing the V2G power module. So if we want to use a V2G function with this charger, we must have a V2G bidirectional power module. The standard power module, it doesn't have the V2G, but it's always possible just to replace with a V2G power module when we release that. And of course, like it's not that it's not like you just change a V2G and then you can have the V2G. Of course, software optimization is there, but it is possible that you get this product, and in future, if you want to have a V2G functionality, it's possible that you just spend very less money and do some upgrade on the hardwares, and you can still use this product. Yeah. All right. Battery specifications. This is a lithium iron phosphate cell we use, and the total battery voltage is 768 voltage on DC. And we have the number of battery cabinet. We have one cabinet, and the total battery capacity is 241 kilowatt hour. Okay, so you have like 241 kilowatt hour. So that means if we look at that, if we charge one car, which is like, let's say like we are charging one car, which is like 40 kilowatt hour, taking 40 kilowatt hour. So that means like you have almost like 5 cars you can charge with the battery, only just depending on the battery. Yeah. And the discharge rate is like 0.5 C. And of course, like you have maybe like questions, how long I can use the battery, right? Yeah. So that's the specification, the 25 degrees Celsius. Let's say if we discharge the battery in 2C rate, then the DOD it's 80%. The end of life is 80%. Then the cycle can get 4,000 cycles. That means if we use the battery daily, that's about like 10 years of life. If we use the battery, charge and discharge every day, we can use like 10 years of the battery. But of course, like when the battery state of health comes to 80%, it's not like that we cannot use the battery anymore. You can still use the battery. Of course, it's not like after 10 years, you have to like change everything, all the batteries. No, you can still use, but you can access to the 80%. Yeah, so it degrades. Like it happens because it's a chemical. It's the common chemical reaction of the battery. So yeah, it degrades. Battery degrades. But all right, but the ROI is faster, right? So you know that that this product, what kind of problem it solves, and you have a faster ROI with this kind of solution. So just to give you an example, like when we use the battery in the normal room temperature, which is 25 degree. So if we use 2C, it's higher, right? So if we charge and discharge in the higher rate and cycle it 80% each time, so it will last at least 4,000 cycles before the capacity drops to 80%, right? So from 100%, it drops to 80%. So in practice, that means over 10 years of daily using, like charging and discharging of the battery. Okay. Till what associate, I think I already explained your questions. What about weight? Okay, I don't have the correct weight data right now, but of course, yes, I can get it and let you know. Yeah, about the EOL. Yeah, I think, yeah, this I already explained about the end of life. So that's the like 80%. Of course, like we can do a lot of optimization. This is not like fixed, right? We can do a lot of optimizations, like to prolong the battery life. We can use EMS to control and make a smart grid with this product, right? Yeah. All right. Now let's look at the very simple like diagram of the different components we have. So the red dot is basically the product, the EVMS one. So everything you see inside this red dot is the components inside. So we have the AC bus bar, and we have the DC bus bar, and we have a PCS, which is a bidirectional inverter. So basically it converts the AC to DC and also DC to AC. It's a bidirectional converter, just using one module. And of course, we have the battery, then we have the EV charging system inside. And you can add solar, right? And this is the solar inverter, which is like converting the DC to the AC, then connecting to the AC bus bar. And the grid, okay, so grid is like 0 to 125 kilowatt. It's because the PCS is 125 kilowatt. So again, this is our standard product. So that's the biggest we could fit inside the cabinet because our goal was to make the product very compact. Yeah. All right. So the grid, it takes from 0 to 125 kilowatt, and of course it connects to the AC bus. Then the AC comes to the PCS, and after the post PCS, it's all DC, right? So we have a DC bus, then the battery, it's connected to the DC bus. And because we are using the DC-DC power module in the EV charger, so that's a DC-DC EV charger, and which is 120 kilowatt and connected to the DC bus bar. So PCS, power conversion system, is our own product, and which is like 125 kilowatt. We use like one piece of that inside. And battery pack, which is like one cabinet of 241 kilowatt hour, and three pieces of 40 kilowatt DC-DC power module, which makes it 120 kilowatt. So I have tried my best to keep it as simple as possible of this slide. So if you need the technical data sheet, we have more technical details on this, giving the specifications of the PCS. I mean, I cannot cover all the specification in 1 hour, and I don't want to take a lot of your time, given that everyone is very, just don't want to occupy a lot of your time. So I will keep this webinar within 1 hour. But let us know if you have any questions. We can always give you more technical details of the product. We have prepared a lot of like PCS data sheets, battery data sheets, the power module data sheets, and more information we can send to you. All right, so just moving to the next slide, right? So now we will look into how the power flow goes. So before we start, I think we have some questions. How about if the grid will be weak and limited to 50 kilowatt only? Can we use it and use full power? Of course. I mean, like now I will explain you like how the grid, this product is specially designed when your grid is weak. So if your grid is weak, you need this product. This is why we have developed this. Your grid like very weak, like 50 kilowatt, no problem. You can still have 120 kilowatt of charging because we have solars, we have battery, right? I will explain you different modes it has and how it solves the problem. Can we get this presentation after the online event? Yes, of course. Like this webinar is being recorded, and we will upload the file to the YouTube and send you the link. Yeah, no problem. Okay, PV inverter is your solution or other? Okay, in this standard solution, it's not our PV inverter. So it's not an integrated, we have MPPT, of course, but sadly in this cabinet, we cannot put the MPPT inside. So because of the compactness, but we also have solution, like we can make it more prolonged, like extensions more, because you know that our advantage is having a modular system. So we can add inverter. But to answer to your questions, the one you see now, the standard solution, no, it's not an integrated inverter. It's like external PV inverter. Okay. Since battery capacity is 240 kilowatt, how long it will take to charge from just solar? Yeah, so it's depending on the power you can provide from the solar, but you know that the maximum power to charge the battery, it's 125 kilowatt because our PCS is 125 kilowatt. Yeah. So it's like if you're giving the full power, it will take like 1 hour. You can have 125 kilowatt hour. Then let's say like like less than 2 hours. Yeah, you can fully charge the battery. But practically, you will not discharge the battery to 0%, right? So there will be some state of charge. Maybe if it's 20%, 15%, we can change, swap between the grid and PV. Yeah, I will explain you how the power flows. What is the rating of PV inverter? So you can use like maximum, in this standard solution, maximum you can use 125 kilowatt of the inverter. Yeah, because the PCS power is like 125 kilowatt. PV inverter is separated device. Yeah, I think I already answered this question, right? Why PV is not directly connected to DC bus? Okay, because it's not MPPT. If it's MPPT, we could connect straight to the DC bus. Yeah. Can the charging discharging happen simultaneously? Of course. Like we don't want a product which will be like I can only charge now, or I can only charge the EV now. So when I charge the EV, I don't charge the battery, or when I discharge. So we don't want that kind of thing. It's a simultaneous. Like the priority is to charge the car. So the EV is the priority because this product is basically an EV charger with battery. So of course we can charge the battery when we are supplying power to the EV. It's possible. Yeah. All right. I think I covered the questions for now. So let's look at the different power flows. So we have like 5 different modes, right? So grid priority. So that means like depending on your country, depending on your regulations, if you can feed back the power to the grid, right? Depending on that, we can use the aggregator prices. If the price is higher, then we use less grids. If the price is lower, the energy price is lower. Of course, we want to prioritize the grid to supply to supply to the charging and then charge the car. Depending on the situation, like you can decide if the PV is absent, is PV is offline, the only source is grid, and then your battery is enough, and you can just charge the EV, right? And when there is no car charging and the price is very cheaper, then we can charge the battery, right? Just use cheaper electricity to charge the battery. And then when EV comes, if the grid price is higher or no grid at all, we can use the battery or we can use the solar. Like, yeah. So we have a lot of flexibility now. The priority is to charge the EV with full power. Okay, so that's like we call it like grid priority. It's depend on the energy prices or depending on the availability of the grid. So I just take an example of 125 kilowatt, but don't get confused. If the grid is 5 kilowatt, it still works. I just put a maximum number because the maximum we can take from the grid is 125 kilowatt. Again, this is a standard product. Yeah, it can be scalable. Yeah, according to your needs. So the standard product says that the PCS is 125 kilowatt. Then yes, of course, the maximum power is 125 kilowatt. So it's 0 to 125 kilowatt. Yeah, that's the grid priority. Let's, I think someone else is joining. Okay, I have, yeah. Don't worry if you join us late. I mean, I think you have missed some of the presentation when you just joined now. Don't worry, we will put this presentation into YouTube and send you the link. Yeah, don't worry. So you haven't missed anything. Yeah. All right. So grid priority. Let's look at the next, the mode we have. We call it battery control. So that's basically like the prioritizing the battery to charge the car. Of course, like it's completely depends like on the SOC, and let's just think like that. We charge during the low electricity price. So that when the price is very low, we charge the battery. So we have two different sources. Of course, the PV is the priority all the time if there is solar. So we always use PV to charge the battery, keep on, or maybe if the battery is already enough, we can use PV and charge the car because that's the free electricity for us when the solar is already installed. So our main priority to use PV as the source to charge the battery or charge the car. But yes, PV is not constant, right? So um, we always can do like this, like we use cheaper electricity to charge the battery and, like use the battery when the grid is expensive, then we can use the battery to power up the EV. Yeah. So actually the power flow is very simple. So we just use this product to maximize our revenue. This is the purpose to have this kind of product to speed up, boost up the ROI. That so this product is designed to use less money and generate more revenue. So we will always use which is cheaper or free, right? Okay. And you control everything. It's not a fixed, it's not a static algorithm. You can always manipulate with the algorithm. You can always decide how this product should work. Yeah. All right. Let's look at the next mode. We call it grid plus battery boost mode. That means like we use the grid and the battery together to charge the car. So that means when the battery's energy is not enough, let's say like the battery energy is like you are at some point that the battery is 40%, right? And then you can use more power from the grid, or you can use symmetrical power. Uh, so you decide, like you are in the control, like you decide how much you should take from the battery and how much you should take from the grid. So we call it like booster mode. So together, grid and battery together, you boost the power and then charge the EV. Yeah. All right. So in this mode, the power, which is like the grid power, the flow is going through the PCS. So our PCS, it's a AC DC DC AC bidirectional inverter. That means when the grid is flowing the AC to the PCS, and then PCS is converted the DC and supplying power to the EV charger. And of course, the same like the battery is also like supplying the power to the EV, so EV can get the maximum power. So again, the priority is to have a full power, full charging power to charge the EV. This is the priority. So we will use different sources and make sure that I have always highest capability of the charging power to charge the electric car. Yeah, that's the purpose of this product. Yeah. So we have seen grid priority, battery priority, and grid plus battery booster mode. Let's look at the PV priority. Yeah. I will wait 7 to 8 seconds to deal with the internet latency. All right, I think that now you can see my slide. Yeah, I hope so. You can see my next slide. So we call it solar priority mode. That means like the solar power is, we always prioritize the power from the solar. Of course, it's during the daylight, during on the forecast. So tomorrow there will be a very bright sunny day, and we know, okay, tomorrow doesn't matter for the charging or for the battery, we will prioritize the PV. So yeah, so PV can like charge the EV. I mean, going through the flow will go through the PCS. Then the PV, if PV is enough, let's say like if PV is more or like close to 120 kilowatt, or doesn't matter if it's 120 kilowatt, the purpose is to utilize all the power from the PV. So when the PV is like enough and my battery is already full, so I don't need to charge it. So I can always use the PV to charge the battery, charge the car, sorry. And let's say PV is 100 kilowatt and the charging needs 20 kilowatt. So additional 20 kilowatt we can always use from the battery, right? And it is also possible to use all these three sources to charge up the battery, but that's not going to be the case if you optimize the system. The purpose is like when we have a very weak grid. The purpose is when the electricity price is fluctuating to take the advantage of that and use more battery, more solar to charge the EV. That's the purpose. So yeah, this is the solar priority mode. We always prioritize the PV to supply the power to the EV. And if it's, let's say now my car is charging and I just need 80 kilowatt, PV is producing 120 kilowatt. And in that case, we can provide the 80 kilowatt to the charger and the additional 40 kilowatt, we can charge the battery. So we are not wasting the solar power and taking advantage of this system, the smart system. We can always decide how much power flows to where. Yeah, so that's the flexibility this product brings to you. And you can always decide depending on the situation. Like today, it can be a power flow can be like that. Tomorrow, it can be like that. Or you can pre-program that you know that, okay, every day I will use like that. And you are sure that there will be no different situation. Then yeah, you can just pre-program everything and then the charger will do according to you command the charger. And of course, you can take the control over of the algorithm. You can always manipulate with the system remotely and locally. Yeah. So that's the solar priority mode, the fourth one. And the fifth one is like the grid response mode. Like this is like not the product is meant for. I mean, selling the energy to the market. But this is an advantage. I mean, from the hardware and software base, there is no limitation to flow the power back to the grid. But the purpose of this product is like to solve the weak grid problem and have more power. But yeah, of course, just to show you that you are not limited to that only. You can send back the power to the grid to the grid and then make money. But of course, it's depending on the regulation, the grid regulation in your area or the area you will install the battery. If there is a regulation that you can sell the energy to the market and how much you make, so you decide. I mean, according to your operation purpose, you decide what to do. But from the hardware based, from the product based, it is possible to flow the power from the battery to the grid and generate more revenue. Yes. Okay, so that was the grid response mode. That was like 5 different modes we had. I will just take some questions then. Yeah. Will the product also work as an independent split dispenser charger with the battery? Without the battery. So actually this product is an integrated battery. So if you don't need a battery, you can just buy our EV charger. Yeah, no problem. We have just independent EV charger we have independent battery energy storage system. So if you don't need the battery, of course, you can just buy the EV charger. But if you're looking into having all this kind of PV and different algorithm into the system, yeah, I think it's depends if your grid is enough. Yeah, I don't know if I got you correct. Yeah, I think that you are looking into all this smart algorithm, but without the battery. This is what I understood from your question. Yeah, welcome. What is the maximum power of this charger? Yeah, so the standard product is 120 kilowatt, but yeah, we can have more power. We can scale more power. But this product, EVMS one, it's 120 kilowatt. So I will just take maybe more 5 minutes to show you more solution. As I told you, like I have some interesting slides for you. This is, we call it MCS. So the megawatt charging system. We are now developing the MCS, which is like 1 megawatt of charger. So you can have the same thing. I mean, whatever I explained to you in this webinar, it's the same thing. It's just the power battery capacity is huge now. You don't hear me now? Hello? Let me see. Until now. Hello. Do you guys hear me now? Okay, you hear us. Okay, great. That's great. How many 40 kilowatt power modules there are? Yes, we have like 3 pieces of 40 kilowatt power module. Yeah, it has this dynamic load balancing capability, and also you can limit the power the charger takes. Yeah, so yeah, dynamic power sharing is possible. Okay, so I see a lot of questions about more power. Yeah, I think this one also solves the problem. Of course, this is an MCS level charging solution for the trucks, big buses or cars and everything. So we are developing this MCS megawatt charging system where you can have still solar, can have big batteries. You see up to 2.58 megawatt hour battery capacity. So 40 feet container, 20 feet container, 10 feet container. You can have like different battery capacity. Only difference between them, this is not an integrated, and it cannot be integrated into one cabinet because it's huge. Yeah. So you see that it's a liquid dispenser. It's with MCS, and we have 2 different specification for now. It's 500 ampere with liquid cooling and 1500 ampere with liquid cooling. And of course, you can have a traditional CCS2 because we have the TCS2 dispenser. And this master, it's 1 megawatt. So 1 megawatt of charging power comes from this master with the help of the battery and solar. This is the diagram, like you have grid and PV. Then this is our bidirectional PCS module, and we can add a lot of PCS module according to the power we need. And this is the DC-DC power module, right? And then we have the battery over here. To support the megawatt charging system, we must, I think, like to have a 1 megawatt of the power from the grid, it will be a little bit hard, depending on the country, of course. But now you know that it's possible to have this MCS, even if the grid is 100 kilowatt or 200 kilowatt, or not 1 megawatt. So you can use the battery to support all the power. Okay. And of course, the battery energy storage system is still a traditional energy storage system. You can sell the electricity to the energy market, right? When the system is in idle state, nobody is charging, you can use the battery as a traditional BESS system. And then, yeah, you can sell the power from the battery to the grid and take the advantage of the negative energy prices. And also you can use the battery to support the grid to regulate the frequency. It's FR, frequency regulation. So yeah, you can maintain a healthy power grid with the help of the battery. So what is the MCS? I mean, it's very amazing. I just give you one example. Like this is BYD MCS in China. The charger is 1 megawatt, so 1000 volt and 1000 ampere. The discharge rate is 10C. Yes, they go up to 10C. It means you have 400 kilometer of range just in 5 minutes. Yes, just 5 minutes you get 400 kilometer of the range in the battery. Yes, it's very amazing that the charging speed. Yeah, of course it's MCS with battery. Or 10 minutes of charging, you can get 80 kilowatt hour. Yes, 10 minutes, 80 kilowatt hour. That means each second you get 2 kilometer of charge. I mean the range. Yeah, each second 2 kilometer of the range. So that's like as the same speed of refueling the fuel. So the charging and fueling the petrol into the truck, it's like almost the same time. Yeah. So that's the beauty of MCS, like megawatt charging. So that was actually all I have prepared for you guys today. So again, I tried to keep everything as simple as possible, not too many technical things, just for you to understand what kind of thing this product can do. And feel free to reach us for any questions you have or any data sheets you need. We will send all the data sheets you need, and I'm just putting my email so you can get straight to me, or please contact our team if you need any documentation, and we will put the videos in the YouTube. I have just one question here. What is the maximum power of each gun when both guns are engaged? So if it depends on the car. I mean, the charging is a passive, so we have like 250 ampere. Each gun is 250 ampere. So that means like if Tesla needs 120 kilowatts, then it will get 120 kilowatts. And if like when the SOC drops, or let's say I'm charging with 40 kilowatt, or I'm charging with 60 kilowatt right now, and then there is another vehicle comes. If he can take 60 kilowatt charging, we'll give it to 60 kilowatt charging. So the charger is capable to provide full power on one gun, or split the power between them, like let's say 30 90 60 60. So it's like it's like goes by 40 40, right? So I can go 40 80 80 40 0 plus 120. So it's depending on the EV it comes, but we always prioritize the depending on the SOC. The slower SOC, lower SOC gets priority. Can you share the slide to me? Yes, of course, we will send the slides to you. Don't worry. And also the video to you. What is the minimum grid power for this battery charge to function? It's 0. I mean, like you can have, let me just take the slides back to the, yeah. So just a second. I think it will take 6 to 7 seconds maybe for the latency. Yeah. So so the grid is like 0 to 125 kilowatt. I mean, if there is no grid, then we only rely on the solar. If the grid is weak, 10 kilowatt, 15 kilowatt, or the maximum you can take, like with this standard product, you can get like 125 kilowatt from the grid. What is the maximum power of each gun when both guns are engaged in EVMS? Okay. So I think I already explained that. I mean, if one gun is engaged, it's 120 kilowatt, and if both guns are engaged, it depends on the car. Like let's say the car SOC is lower, it's engaged with 80 kilowatt now, so I have left 40 kilowatt. So when the second EVs come, I can engage 40 kilowatt to them. Or when that car is dropping, SOC is higher, that car doesn't need that much power, then we switch to the lower SOC EV. So it's a dynamic situation between the distribution of the two guns. Yeah. What's the price range of these products? Yes, so I think I will ask. You can ask our sales team, and they will give you the quotation right away. Yeah, and give you all the specification of the technical specification and the commercial specification. All right, guys. I think okay. Another question. Could you send detailed information of MCS system vessels? Of course, yes. Of course, yes. But just to give you some idea that we are developing the MCS, the controller, we are now developing the communication MCS, but we already have designed the product. We're just working on the communication because MCS communication, it's the same as CCS2, but there are some different specifications of the CP voltage and something like that. So we have to optimize for the MCS. But the same controller will do the CCS2, same controller will do the MCS. Yeah, so you can use both CCS and MCS into one charger. Yeah. So, all right, then this video will be, this webinar's video is recorded already and it will be uploaded to YouTube. Okay, just one question. MCS means for distributed high power, like what you have showed. Yeah, yes, okay. Yeah, so I got your idea. So I mean, you are looking for, I think, this MCS solution. Yeah, yeah. We will send you more information about that. I have to check. I am not sure about that, but yeah, you need that BIS certification. Yeah, for that specific region. We are well aware about that. Yeah, but I think we can work out on that to send you this product from here. There are some solutions on that. All right, then anything? Okay, I think someone just joined. We are about to finish this webinar because I already crossed more than 1 hour. I don't really want to occupy a lot of your time. So yes, so we really want to hear your feedback on all the solution we have discussed today, and because this product is like designed for you. So we really looking forward to have your feedback, well, about your suggestions, about what you think about this operation, or what kind of different things should we consider. Please give us your suggestions. Okay, this is what we always look for. And okay, yeah, so that's all then. That's all for today. And please, if you have any commercial queries, please get in touch with our team. You can send an email to us, or you can contact with our salesperson, so that we will assist you in every way, and we try to give you faster feedback. And if you have any questions, technical questions, and anything, any questions you have, I put my email over there. Just send email to us, and look forward to hear you. And we will provide you this slide and the YouTube. We are going to a holiday day after tomorrow for 8 days. So hopefully, if we can upload tomorrow, and then we will send you the slide and the video together, and we will mail you that. So that was all for today, and I really appreciate your time. It really like encourages me to host more webinars every month, when I have all this wonderful interaction with you. So I'm looking for the next webinar. We host webinar each month once, like end of like the fourth week of the month, and looking forward to have you on my next webinar. Thank you everyone for all your time. We will see you on the next webinar. Have a good day.